line yesterday. This is total war.
Keep that line going. Move it!
The year was 1940. Europe was a flame liberty, teetering on the brink, and America stood at a crossroads, desperately unprepared for the storm gathering on the horizon. Into this palpable tension stepped William S. Knudsen, a 61-year-old Danish immigrant, a man who had forged his legend from bicycle mechanic to the very pinnacle of American industry, the president of General Motors. He strode into a Pentagon conference room, a civilian amidst a sea of starched uniforms, facing a table of seasoned Army generals who frankly thought he'd lost his mind. Their faces were etched with skepticism, one even daring a laugh as Knudsen unveiled a promise that sounded like pure fantasy. He would build tanks the same way Detroit built Chevrolets. Not hundreds a year as America's meager 331-unit production in 1940 suggested, but thousands per month, a torrent of armor rolling off assembly lines, run by civilians who'd never even smelled gunpowder. The generals scoffed, clinging to their outdated notion of craftsmanship of tanks painstakingly forged one by one like medieval swords. But Knudsen wasn't bluffing. For 3 decades he had mastered the Ford production philosophy, understanding that complexity shattered into simple, repeatable steps yielded industrial miracles. A tank wasn't some mystical weapon. It was steel rivets and engine tracks. If America could churn out 15,000 cars a day, it could build 500 tanks. The math was brutally simple. The execution would be hell on earth. The Army's Ordnance Department, steeped in tradition, recoiled. This wasn't efficiency. It was sacrilege. They saw the automotive industry's arrogance an insult to their decades of meticulous custom manufacturing. Yet Knudsen had heard it all before, back when Henry Ford's assembly lines were deemed barbarism. Now, with the fate of nations hanging by a thread, he was betting America's very survival on that same ruthless industrial logic. He'd already crunched the numbers: millions of square feet of idle factory space, countless unemployed workers ready to fight for freedom with wrenches instead of rifles. The only missing pieces were permission and a tank design simple enough to be mass-produced. When the British M3 medium tank specifications landed in July 1940, demanding a mere 1,000 units, Knudsen saw his destiny. He quietly instructed his engineers to prepare for 10,000. The stage was set, the impossible dream ignited. If you're captivated by this untold story of American ingenuity and grit, make sure to like this video, subscribe to our channel for more historical narratives, and share it with fellow history enthusiasts. Roosevelt gave him the authority on May 28, 1940, creating the National Defense Advisory Commission, with Knudsen as Director of Industrial Production. No salary, no official military rank, just unlimited power to retool American manufacturing for war. Knudsen walked out of that White House meeting and immediately called Detroit. Chrysler's tank arsenal would break ground within 90 days. He gave them a target that made his own engineers nervous. 1 tank every hour within 2 years. It wasn't a goal, it was a demand. Either American industry would achieve the impossible, or the Nazis would be unstoppable. There was no middle ground. The race had started, and Knudsen had just promised to win it using civilians who didn't even know what a tank looked like yet. Pearl Harbor changed everything overnight. On December 8, 1941, Knudsen's theoretical production plans became America's only lifeline. The phone lines at the War Production Board burned hot as factory managers across Michigan, Ohio, and Pennsylvania received identical orders. Stop making whatever you're making and start building tanks. Now, the Cadillac plant in Detroit that had been stamping luxury car fenders was suddenly expected to forge tank turrets. Fisher Body, famous for sleek automobile curves, got blueprints for armored hulls. Nobody had done this before. There was no manual titled "How to Convert Your Buick Factory into an Armory in 3 weeks." They were inventing the process. While German panzers rolled across North Africa and Soviet T-34s burned in Ukrainian fields, the chaos at the Chrysler tank arsenal in Warren, Michigan during January 1942 looked less like precision manufacturing and more like controlled panic. Workers showed up to buildings where concrete was still curing on the factory floor. The assembly line existed only as chalk marks on bare ground. Crates of tank components arrived before anyone knew where to store them, so they piled up in parking lots under tarps. Forklifts navigated between construction crews still installing overhead cranes. The first M3 Lee medium tanks assembled there in April 1942 were basically hand-built, taking 2 weeks per vehicle slower than the craftsman approach Knudsen had promised to replace. Engineers stood on the factory floor, literally rewriting blueprints in real time as they discovered tolerances that worked in prototypes failed at scale. Training became the nightmare nobody had anticipated. You could retool a building in months. But how do you transform a laid-off restaurant cook into someone who could weld armor plate that had to stop armor-piercing rounds? The traditional approach apprenticeships lasting years was impossible. Knudsen's training director, a former Ford efficiency expert named Carl Bailey, created a radical solution. They broke welding into exactly 17 specific techniques needed for tank production. Nothing more. A recruit didn't learn to be a master welder. They learned to make one perfect weld in one specific location over and over, 10 hours a day. It was the assembly line philosophy applied to human beings. Critics called it dehumanizing. Bailey called it the only way to build 1,000 tanks a month with workers who'd never held a welding torch 3 weeks earlier. The material bottlenecks nearly strangled production before it started. Armor plate was the critical constraint. Only a handful of American steel mills had the rolling capacity to produce the thick, hardened steel required for tank hulls, and they were already backlogged supplying shipyards. In February 1942, Knudsen personally visited Bethlehem Steel's plant in Pennsylvania and made an offer the CEO couldn't refuse. Government financing for a new plate mill that would triple their output, but only if they delivered the first run to Detroit within 90 days. They did it in '87. Meanwhile, the shortage forced engineers to get creative. The M3's riveted construction, which traditionalists had insisted on, became a liability. Rivets took time and required pre-drilled holes with precision tolerances. Welding was faster, but required higher skill. The compromise: teach welding faster, simplify the joint designs, and accept a 15% reject rate that quality control would catch. By March 1942, the Chrysler line finally started hitting rhythm, producing 4 M3 Lees per day. It was nowhere near Knudsen's vision, but it was movement. Then the Army changed everything again. They wanted the new M4 Sherman instead. A better design, but completely different production requirements. Every jig, every tool, every training program built around the M3 became instantly obsolete. Knudsen didn't flinch. He'd been expecting this. War doesn't wait for perfect conditions. You adapt or you lose. The retooling began immediately, even as M3s were still rolling off the line. 2 assembly lines, 2 tank types, 1 factory, 0 margin for error. Welcome to industrial warfare, American style. The M4 Sherman that arrived on blueprint paper in August 1941 was a 30-ton mechanical nightmare for mass production. It contained roughly 8,000 individual parts, not counting the 5,000 rivets. Some variants used. The Wright R-975 radial aircraft engine alone had 847 components. The transmission required 23 precision gears machined to tolerances of 1/0 of an inch. The vertical volute suspension system used 48 bogie wheels per tank, each needing individual rubber cushioning. Army Ordnance had designed it for battlefield superiority, not factory efficiency. Knudsen's engineers took one look at the specs and knew their job was surgical. Dissect this beast, simplify everything possible, and make it so straightforward that someone's grandmother could assemble a section without screwing it up. The breakthrough came from a GM engineer named John Whittley, who'd spent 20 years designing Cadillac transmissions. He gathered the team in September 1941 and drew a radical concept on a blackboard. Treat the Sherman not as one integrated machine, but as 7 major sub-assemblies that could be built simultaneously in different locations, then married together in final assembly. hull turret, engine transmission, suspension, electrical, armament. Each sub-assembly would have its own dedicated line feeding into the main artery. The hull alone got broken into 22 separate stations, each performing one specific task. Station 7 did nothing but install the transmission mounting brackets. Station 14 existed solely to weld the bowgunner's hatch. This wasn't tank building anymore. It was choreographed industrial dance with 300 workers, each performing their individual moves in perfect sequence. Ford's River Rouge plant took the philosophy even further with their version. They vertically integrated everything. Knudsen had watched Henry Ford build a factory where iron ore entered one end and finished cars drove out the other. Now they'd apply that to armor. Raw steel arrived at the Rouge plant's blast. Furnaces got rolled into armor plate, in their own mill cut to size in their stamping facility, welded into hulls in Building B, mated with engines from Building C, and completed tanks rolled out the opposite end 48 hours after the steel had been molten. Every Sherman component except the main gun was manufactured on site. When a design flaw appeared, they could fix it in the steel mill and see the correction on finished tanks within 2 days instead of waiting weeks for outside suppliers. Speed wasn't just about moving fast. It was about eliminating every delay in the chain. The turret presented special problems. Early designs required a massive casting, one single piece of formed steel weighing 3 tons. Only a handful of foundries in America could pour castings that large, and the reject rate was brutal. Nearly 40% of turret castings failed quality inspection because of air pockets or cracking during cooling. Each failure meant remelting tons of steel and a 2E setback. Pacific Car and Foundry in Seattle solved it by developing a welded turret design using flat plates instead of one complex casting. It was heavier, less elegant, and ordnance officers hated it on principle, but it worked, and more importantly, production yield jumped to 94%. Knudsen approved the change immediately over Army objections. Tanks on battlefield beat perfect tanks on drawing board. That was his only standard. Standardization became religious doctrine when multiple factories started producing Shermans. Chrysler, Pfizer, Ford, Federal, Machine, Pacific Car, Press Steel, Baldwin Locomotive. Each plant initially wanted to make improvements to their design. Chrysler thought their transmission was better. Pfizer wanted a different engine mount. Knudsen shut it down brutally. Every factory would build identical Shermans using identical specifications, identical tooling, identical processes. Parts had to be interchangeable across every tank, regardless of which factory built it. A transmission from Detroit had to drop perfectly into a hull from Chicago. This wasn't about engineering pride. It was about battlefield logistics. When a Sherman threw a track in North Africa, the repair crew didn't have time to check which factory built it before grabbing replacement parts. Standardization meant a tank damaged on Monday could be fighting again on Tuesday. Variety meant death. The workers flooding through factory gates in early 1942 looked nothing like the precision machinists Army brass had envisioned building their tanks. Anna Kowalski had been serving coffee at a Detroit diner 2 weeks before she found herself welding hull plates on the Chrysler line. James Washington, a 8-year-old Alabama sharecropper, had never operated anything more complex than a mule plow. Now he was installing transmission assemblies. Margaret Chen, barely 5 feet tall, climbed into turret compartments to wire electrical systems in spaces engineers had assumed only small men could access. Over 4,000 people worked Sherman production across multiple plants. By mid-1942, and roughly 65% had zero manufacturing experience. Knudsen had predicted this. Wars aren't won by waiting for skilled workers to appear. You create them from whoever shows up. The training system Bailey designed was brutally efficient because it abandoned the idea of creating well-rounded craftsmen. On her first day, Anna didn't learn welding theory or metallurgy or proper torch angle for 8 different materials. She learned one weld the vertical seam where hull side meets hull bottom on the M4A3 variant. That's it. Her instructor, a former pipeline welder from Texas, spent 4 hours showing her the exact torch distance, precise feed rate, and specific motion pattern. She practiced on scrap metal for another 8 hours, until the bead looked identical every single time. By day 3, she was on the production line, making that weld for real, dozens per shift. Station 23 became her entire universe. She got so good at that one specific weld that her reject rate dropped to under 2%, better than workers with 10 years of general welding experience. The speed of training created quality control nightmares that nearly derailed everything. In March 1942, a batch of 47 Shermans failed Army acceptance tests because internal welds on the ammunition racks were substandard. They'd crack under sustained firing vibration, potentially detonating the tank's own shells and killing the crew. Inspectors traced the problem to one training class, where the instructor, overwhelmed by 200 new recruits, had cut corners on teaching proper penetration depth. Those workers had been making bad welds for 2 weeks before anyone caught it. Every tank they'd touched had to be pulled, disassembled, re-welded, and re-inspected. The delay cost 11 days of production. Knudsen's response wasn't to slow down training, it was to add inspection stations. Every 7th Sherman got completely disassembled by quality control teams who checked every weld, every bolt, every tolerance. Brutal, wasteful. But it caught problems before tanks reached battlefields. The factories ran 3 shifts, 24 hours, 7 days a week. The night shift, 11:00 p.m. to 7:00 a.m., was the hardest. Workers called it the zombie shift because you never adjusted. Human bodies aren't designed to work when every biological instinct screams for sleep. Productivity dropped 15% on night shifts, and injury rates doubled. Dorothy Martinez, working the turret assembly line at Pfizer Body, fell asleep standing up at 3:00 a.m., and her hand drifted into a moving conveyor belt. She lost 2 fingers. The factory didn't stop. Her station was filled within 20 minutes by a floater worker who'd been trained for exactly this situation. Dorothy was back on a different station 3 weeks later because missing fingers didn't disqualify you. Only missing hands did. The cold calculus of wartime production meant everybody that could contribute did contribute. The workforce transformed the factories into strange communities. Since many workers had relocated from across America chasing defense jobs, they essentially lived at the plants. Chrysler built on-site dormitories housing 3,000 workers. The cafeteria served 5,000 meals per day across all shifts. A barbershop, medical clinic, and even a small post office operated inside the factory complex. Children attended daycare and converted storage buildings, while mothers welded armor plate 200 feet away. The line between civilian life and war production dissolved completely. You ate where you worked, slept near where you worked, and your friends were the people who worked your station. When the PA system announced Allied victories in North Africa during lunch breaks, the cheers echoed off steel rafters because everyone understood those were their tanks winning those battles. Every Sherman rolling off the line carried a piece of 4,000 individual stories, most of which would never be told. April 12, 1943 marked the moment Knudsen's impossible promise became reality. At the Grand Blanc Tank Arsenal, a sprawling complex covering 113 acres of former Michigan farmland, Sherman No. 1000 rolled off the line at 2:47 p.m., exactly 55 minutes after Sherman 999. The plant had hit the rhythm Knudsen had envisioned 3 years earlier, when generals laughed at him. One complete M4A3 Sherman medium tank, fully assembled, every system tested, ready for combat, emerging from final inspection every 55 to 60 minutes, hour after hour, shift after shift. The Germans were producing roughly 500 tanks per month across their entire industrial capacity. Grand Blanc alone was matching that number, and it wasn't the only Sherman factory. Walking the Grand Blanc line during peak production felt like witnessing industrial ballet choreographed by a madman. The main assembly line stretched nearly half a mile. Overhead conveyors carried major components, hulls, turrets, engines, in perfect synchronization. Every 5 feet represented 1 minute of production time. At the line's start, raw welded hulls arrived from the fabrication building, still warm from final welds. Station 1 workers had 55 seconds to bolt the transmission mounting frame before the hull moved to Station 2. Nobody rushed. Rushing meant mistakes. Instead, every motion was optimized down to the specific hand used to grab each bolt. The workers moved with the mechanical precision of the machines they were assembling. Because they'd repeated these identical motions 400 times per shift for months, the suspended track assembly system became the line's most recognizable innovation. Traditional tank production required workers to manually lift and position the heavy track sections. Brutally hard work that slowed everything down and injured backs regularly. Grand Blanc engineers suspended the tracks from ceiling-mounted cranes that moved in sync with the assembly line. As each Sherman progressed, its tracks descended at the exact moment the suspension bogies were ready. Workers guided them into position, and pneumatic tools drove the connecting pins home in 90 seconds flat. What had taken 45 minutes of heavy labor now took less than 2. That single innovation, replicated across 8 workstations, saved nearly 6 hours per tank. Multiply that by 16 tanks per day, and suddenly you're producing an extra battalion of armor every week from pure efficiency gains. The engine marriage station was where everything either came together perfectly or fell apart spectacularly. The Continental R975 radial engine, weighing 100 pounds, had to mate with the transmission, connect to fuel lines, oil lines, coolant lines, electrical harness, and exhaust, all within a 12-minute window. 4 workers surrounded each tank in a precisely choreographed sequence. Worker 1 dropped the engine using an overhead hoist, while Worker 2 guided it onto mounting studs. Worker 3 connected the transmission coupling, while Worker 4 simultaneously ran electrical connections. They never spoke. Hand signals only. The noise-level hammering welding engine testing metal screeching made conversation impossible anyway. They'd done this exact sequence so many times that verbal communication became unnecessary. Each worker knew what the others would do next, through pure muscle memory. Quality control became a religion, because speed without reliability meant nothing. Every tank at Grand Blanc underwent the death run, a 3-mile course on the factory grounds featuring mud pits, steep hills, sharp turns, and obstacles designed to stress every system. Engines ran at full throttle. Transmissions shifted through every gear under load. Suspensions absorbed impacts that simulated battlefield conditions. If anything failed, an oil leak, transmission, grind, track, throw, electrical fault, the Sherman was pulled immediately, the defect traced to its source station, and the worker responsible retrained on the spot. The reject rate hovered around 8%, meaning roughly 1 in 12 tanks failed initial testing. But those 8 failures meant the other 92 reached North Africa, Italy, and eventually Normandy with systems proven under stress. Nobody wanted their name associated with a tank that failed in combat because training was inadequate. By summer 1943, the combined American Sherman production from all plants hit 2,020 tanks in July alone. That single month's output exceeded total German tank production for the entire year of 1941. The assembly line concept had done exactly what Knudsen promised. It turned American industrial capacity into an unstoppable flood of armor. Soviet officers visiting Detroit factories stood speechless, watching Shermans emerge with metronomic regularity, later reporting to Stalin that American production capability was beyond comprehension. The British, receiving thousands of Shermans through Lend-Lease, rebuilt entire armored divisions around American-made tanks because they simply couldn't match the output. The 60-minute Sherman wasn't just manufacturing achievement. It was the moment industrial capacity became a weapon more decisive than any gun. The telegram from North Africa arrived at Knudsen's office on February 18, 1944, and it carried the kind of news that turns assembly lines into graveyards. American tank crews were reporting catastrophic failures when engaging German Panthers and Tigers. Shermans were burning after single hits. Their thin armor penetrated easily. Crews incinerated inside what soldiers grimly called Ronsons after the cigarette lighter advertised to light on the first strike. The 75 emitter main gun couldn't penetrate German frontal armor beyond 500 yards, forcing Shermans to close to near-suicidal ranges. Crews were refusing to board tanks. Some units reported desertion rates climbing. The Army needed solutions yesterday, and shutting down production to redesign wasn't an option. The factories were producing 1,500 Shermans monthly. and Eisenhower needed every single one for the upcoming Normandy invasion. The engineering team at Chrysler faced an impossible equation: fix critical vulnerabilities without stopping the line. Complete redesign was off the table. They had 4 months until D-Day, and tanks already in production had to reach Europe combat ready. The solution came from battlefield reports themselves. Crews were jury-rigging their own improvements, welding spare track sections onto hull fronts for extra armor, sandbagging vulnerable ammunition storage areas, even attaching logs and spare wheels as improvised protection. If soldiers were modifying tanks in combat zones with scraps, maybe the factory could systematize those modifications during production. The concept of midstream retrofitting was born, changing the product while it moved down the assembly line without disrupting the flow. The ammunition storage redesign happened first because it was the most lethal flaw. Early Sherman stored 75mm shells vertically along the hull sides, convenient for loaders, but catastrophic when hit. Penetrating rounds would strike ammunition directly, causing instant detonations that blew turrets 30 feet in the air. In March 1944, engineers redesigned the storage to position shells flat on the whole floor, surrounded by water jackets, wet stowage that would absorb heat and suppress fires. Implementing this change mid-production required adding 3 new stations to the assembly line without slowing the overall flow. Station 31. A now installed the water jacket systems. Station 31B. Repositioned ammunition racks. Station 31C. Tested the water circulation. Tanks entering the line Monday had old storage. Tanks leaving Friday had wet stowage. No production gap. Battlefield survival rates for Shermans with wet stowage jumped from 60% crew survival to 85%. The armor problem proved harder because you can't add meaningful protection without adding weight. And weight meant redesigning suspensions, engines, and transmissions. The compromise was applique armor bolt-on plates that crews could add based on mission requirements. Fisher Body created standardized kits. Frontal hull plates adding 1 inch of armor, turret cheek plates, even track guards. These kits were manufactured separately and shipped with the tanks, allowing field commanders to configure Shermans for specific roles. Tanks leading assaults got maximum armor. Exploitation units kept weight down for speed. It wasn't elegant, but it worked. More importantly, it worked without redesigning the base. Sherman, meaning the 6000 tanks already in the production pipeline, didn't become obsolete overnight. The 76mm gun upgrade created the biggest production headache. The new high-velocity gun could actually hurt German heavy tanks, but it required a completely different turret, larger, heavier, with modified recoil systems. Ordnance wanted all new production shifted to the 76mm variant immediately. Knudsen's team pushed back hard. Retooling turret production across multiple factories would cost 6 weeks of output. Roughly 2,000 tanks that wouldn't reach Europe in time for Normandy. The compromise was brutal and practical: split production. The Chrysler line would continue 75 lumens, Shermans at full speed. The Fisher line would slow by 30% to retool for 76mm variants. Combined output would drop temporarily, but the flow wouldn't stop completely. By June 1944, both versions were being produced simultaneously, giving battlefield commanders options instead of forcing one solution for all situations. The adaptation process revealed something Knudsen had understood from the beginning. Assembly lines weren't rigid mechanical systems. They were living processes that could evolve under pressure. Traditional military procurement would have halted production, demanded perfection, and delivered the ultimate tank 2 years late. The assembly line philosophy said, keep building fixed problems incrementally and trust that volume creates opportunities perfection never could. A Sherman with wet storage and applique armor wasn't as good as a Panther in one-on-one combat. But 5 Shermans arriving this month beat 1 perfect tank arriving never. The line kept rolling. The modifications kept coming. And most importantly, the tanks kept reaching the soldiers who needed them. That was the only metric that mattered in wartime. Not perfection, but presence. The final production numbers tell a story that German tank designers, blinded by their pursuit of technical perfection, never wanted to hear. Between February 1942 and July 1945, American factories once churning out sedans and refrigerators birthed an astonishing 49234 Sherman tanks. Read that number slowly. Let it sink in, for it represents the industrial chasm that swallowed Axis ambitions whole. Germany, for all its vaunted engineering, managed roughly 6000 Panthers, their superior medium tank, and a mere 1350 Tigers, those feared monsters of the battlefield. On paper, German engineering won every time. On the battlefields of Europe and North Africa, German engineering drowned under an unstoppable, relentless tide of American production. For every Panther destroyed, 3 more Shermans appeared. Math, it turns out, cares little for quality when quantity reaches biblical overwhelming proportions. The Soviet numbers add crucial context to this industrial epic. An estimated 84 tons, 34 seconds, arguably the war's best tank design. Combined American and Soviet tank production reached approximately 1,800 armored vehicles. The Axis powers fighting a 3-front war collectively managed a paltry 5,000. German tank crews reported the psychological horror of destroying 5, 6, even 7 Shermans in a single engagement, feeling victorious only to watch 10 more crest the hill behind them. Tactical superiority became strategically meaningless when the enemy could afford losses you couldn't. Every Sherman brewed up represented maybe 2 hours of American production capacity. Every Panther lost represented 2 weeks of German resources they'd never recover. This staggering replacement rate advantage broke German armor doctrine, completely turning their tactical excellence into a desperate losing battle against industrial inevitability. The strategic bombing campaign's relentless pounding further widened the chasm, crippling German factories, while American production lines, safe and well-fed, ran 3 shifts daily, fueled by unlimited raw materials. Detroit never faced steel shortages. Aluminum was abundant. Rubber flowed from both natural and synthetic sources. After 1943, the resource disparity meant German factories were fighting to merely maintain output, while American factories were optimizing how fast they could build even more. The sheer logistical tale woven by Sherman production was almost as vital as the tanks themselves. America didn't just build 49234 tanks. It built the entire support infrastructure, spare parts, ammunition, fuel maintenance kits, for every single one. German units abandoned repairable Panthers for lack of parts. American maintenance battalions rebuilt damaged Shermans in 72 hours using standardized components that seamlessly interchanged, a true testament to the assembly line's efficiency. Even the crews themselves became part of this quantity advantage. While Germany suffered from fuel shortages for training, American tank crews learned on mock-ups with unlimited ammunition far from combat, then shipped out with brand new Shermans fresh off the line. By 1945, the American armored force was a self-sustaining juggernaut where production, training, logistics, and replacement all moved at the same relentless pace. Germany never had a chance against that kind of systematic dominance. The Shermans didn't need to be better. They just needed to keep coming, and they never stopped. William S. Knudsen died in relative obscurity in 1948, his name largely forgotten by the public he served. No state funeral, no grand memorial. Yet this Danish immigrant, the only person ever to skip every military rank from private to 3-star general, wore the uniform for 3 years without ever firing a shot, doing more to win World War II than most battlefield commanders. Eisenhower himself acknowledged Knudsen's contribution as critical. His assembly line doctrine didn't die with him. It metastasized into every corner of military production, making the arsenal of democracy not poetic language, but official, enduring doctrine. This philosophy, valuing production at scale, continues to shape American military planning from the M1 Abrams tank to emergency vaccine production. But this doctrine came with a searing cost, one etched in the memories of those who fought. The Sherman crews, particularly in North Africa and Normandy, paid the ultimate price, burning inside tanks that were good enough to produce quickly, but tragically not good enough to protect them adequately against superior German armor. The institutional bias towards mass production sometimes meant fielding inferior equipment because it could be built faster. Knudsen's genius was recognizing when quantity mattered more than quality, a brutal calculus of war. The final assessment demands uncomfortable honesty. His assembly line doctrine won World War II. There is no serious debate. The 49234 Shermans, forged by ordinary citizens and delivered by a system that defied military tradition, crushed Axis armor through sheer overwhelming presence. But those same Shermans were objectively inferior to their German counterparts in armor, firepower, and crew survivability. American tankers died in greater numbers because the production system prioritized getting adequate tanks to the battlefield now over developing perfect tanks for later. Was it the right choice? History through the lens of Allied victory says yes, but the men who burned in those Ronsons might have wanted the conversation to be more complicated. Knudsen built the machine that won the war. Whether he built the right machine remains a question without a comfortable answer. What's certain is that no other civilian in American history wielded such immense influence over military victory while remaining virtually unknown. The Danish immigrant who promised the impossible delivered exactly that, then vanished into the footnotes while the world he'd helped save forgot his name. That, perhaps, is the most profoundly American story of the entire war.